Skyscrapers look rigid, but in wind they move. Not by meters, usually by centimeters, sometimes a little more near the top. That tiny motion is expected, measured, and designed. The goal is not zero movement. The goal is controlled movement. When wind hits a tower, pressure rises on the windward side and suction can form on the leeward side. Together, they create lateral force and overturning moment. The facade passes these loads into floors, then into the structural frame. Most tall buildings rely on a central core made of reinforced concrete or composite walls. This core houses elevators and stairs, but structurally it behaves like a giant vertical cantilever, resisting bending from wind. Many towers add strong perimeter columns tied with deep spandrel beams, forming a tube-like system. Instead of one element taking all load, the whole perimeter participates, spreading stress and increasing lateral stiffness. To reduce sway, engineers often connect core and perimeter using outriggers at mechanical floors. These stiff horizontal trusses recruit exterior columns as giant tension compression partners, boosting resistance without filling every floor with braces. Aerodynamics matter. Rounded corners, setbacks, chamfers, and tapered profiles can break up vortex shedding, reducing rhythmic crosswind forces. Smart geometry lowers demand before the structure even has to resist it. Strength prevents failure, but comfort controls perception. Even safe motion can feel unsettling at the top floors. Tuned mass dampers and viscous dampers absorb energy, reducing acceleration so occupants feel stability during strong wind events. Wind tries to tip the building, loading one side of the foundation in compression and the other in uplift. Raft slabs, piles, and rock anchors transfer these forces into soil and bedrock, so the entire tower stays in equilibrium. Engineers design with probabilistic wind maps and code-defined return periods. Service-level winds check comfort and cladding. Ultimate-level winds check strength and stability. Different criteria, same principle. Predictable performance across rare and common events. Long before construction, teams test scaled models in wind tunnels and run computational fluid simulations. If resonance or high drift appears, geometry and structure are tuned early when design changes are fast and affordable. So skyscrapers survive wind by combining systems. Aerodynamic form reduces demand, cores and frames provide stiffness, outriggers spread load, dampers control motion, and foundations close the force loop into ground. Stability is engineered layer by layer. A tall building is not a rigid block. It is a controlled machine for managing wind energy. This is load-bearing, where structural logic turns invisible forces into livable cities.